So now I will introduce the code that I use in this project. So this is the main function, and in this config we define the number of pilots and whether we use noisy CP and the value of SNR and whether we use clipping. So these paths are passed to the pilot files that we have, and this is the learning rate. So now this file has the training and testing process. So we first define the number of bits to be transmitted, which is k here, and the number of CP, and we check whether p is smaller than k, and we assign the carriers. And here are some hyperparameters of the training, and here are some parameters of the network. Because this code is my modified version of using RNN to do the experiment, so these three functions, weight variable, bias variable, and RNN, are the network configuration, and X is a placeholder for the input, Y is a placeholder for the output, W is a weight matrix, and B is a bias. And here we define the learning rate, the cost function, the optimizer, and how to calculate the accuracy. And here we partition the pilot files to be the training files and testing files. And since each file has many pilot sequences, we want to put each sequence in one line using this function. And then we run the TensorFlow session to do the training. Firstly, we initialize all the parameters, and then for each epoch we run a batch, and for each pilot sequence in this batch we generate 1000 bit sequences to be transmitted, and then we put the pilot sequence and these bits into the simulation program, which is OFDM simulate here, which I will introduce later. And then we get the signal output, which is our predicted transmitted signal. And this sequence is appended to the input of our neural network. And the bits are appended to be the output of the neural network. So we have batch X and batch Y, which are inputs and our labels. And we put this batch X and batch Y into the neural network, and we can get our cost. So display step here equals to 5, which means that we do a testing every 5 epochs. So the way to do the testing is very similar, because we also generate 1000 bit sequences for each pilot sequence, and we also get our training testing data by this simulation method, and we get our inputs and outputs of the network, and we just run the network and calculate the accuracy. So this is actually the same part of calculating the training accuracy, and we just print these accuracies in our training process. So our simulation method is in this utensils file, and this is the simulation function. So we can see that firstly we compare P with K and assign the carriers. And then we use IDFT to transform the frequency domain sequence into time domain sequence. And we add CP here. And then we see whether we need to clip. If so, we do the clipping. And this channel function just convolve the transmitted signal with the pilot sequence. And if there's no CP needed, we can remove the CP. So this is our simulation method. And let's see how do we do the clipping. So we firstly get the threshold, which is CL here, and we see which bits are higher than the threshold, and we just clip them here. And how do we add CP? If we find that we need to use noisy CP, we just generate some noisy bits and use them as CP here. If we just want to use ordinary CP, we can just get a subsequence of the sequence that we want to transmit here and use this sequence as our CP. So how do we do the convolution in this channel function? So we first use this mp.convolve to do the convolution, and then we calculate some noise here and add the noise to the convolved sequence. So this is basically my code. Thank you.